We're going to add on just a little bit. We're going to look at some word problems and look at a different type of problem with the recursive and explicit sequence. First thing you're doing, think about what a recursive sequence is. It's the second thing we learned yesterday. Turn and talk to your partner. What's the difference between recursive and explicit? What does recursive always have in it that explicit does not? Turn and talk to
I don't know what any map of recursive like. Me either, dude.
Kind of. 3, 2, 1. Let's head to Julia. Do you remember yesterday, what was that difference in the recursive sequence that we saw? It had this parenthesis thing, and it said n minus 1. Anyone remember what that means? When you see that, what are you thinking of? You should write this underneath your aim right now. Board to paper, this is important for today's lesson. When you see n minus 1, what are you looking at in your sequence? In your table, you're looking at the pattern, and specifically, you're looking at the number that's previous. You're looking at the previous number in the sequence. So when you're looking at n minus 1, you're actually putting in the number that just came before this one. Recursive is the hardest type we'll look at today and see why. Let's talk about explicit first. Explicit looks more like a function. It's pretty simple. It's just more like your basic equation or linear equation. We are going to, this time, look at the sequence, and we're going to find one specific term that's given, then find the position of that term. Box 25, you want to find the number of n when you put 25 in for f of n. So what is the 25th, at the 25th sequence, what is the number for n? On the 25th sequence, what is the number for n? We're going to start plugging things in and solving them. 25 goes in place of f of n. 25 on the 25th sequence, we need to solve for n. That looks like a similar equation that I can solve. Charles, what would I do to both sides? My goal now is to get n by itself to see what I plugged into n to get the 25th. Great. Let's subtract it. Doing partners and independent, I'll let you get a calculator. For now, we'll just use mine, unless someone can do that mentally real quick. 25 minus 6.25. No, not 23. It's 18 something. 18.75. Okay. 18.75. We're close. 1.25 on the right. Zion, what do I do last step? Okay. So this type of problem is really similar to just solving equations. You guys are all masters at that, and you should have it down pretty easily. 18.75 divided by 1.25 equals, nice, n equals 15. That's great. So when it says explicit, you're solving it like a normal equation. You use the number they give you as f of n. What happens if it's recursive? You have a recursive rule for a sequence, and one of the specific terms, we need to find the position of the given term. 5 1/2 is going to go in for f of n. Okay, so if I put 5 1/2 in for f of n, what happens? Can I solve for n this time? Turn and talk yes or no. What's the problem if it's a no? What can I do if it's a yes? Go. Sort it out. What do I do with that? F of n minus 1. Well, did I give you your paper back? There you go. 3, 2, 1. That's a great insight. Hayden, can you roll with that? You said, aren't you supposed to use 8.5? Tell me what you're thinking.
Because yesterday we had it in f of 1, and then if you have to make a table, 1 is 8.5, so then we have to find 2. So then 2,
Right.
use 8.5 to plug it in.
So can I put 8.5 in for here? Oh, this isn't f of 1. This is f of n minus 1. When you have it, recursive rule, these are the most annoying because you actually have to make a table every time. And here's why. You need to roll along starting with f of 1. And you need to figure out, when you have f of 1, that's, they say 8.5. So when the n is 1, you get 8 and 1/2. Well, what happens when you plug in 8 and 1/2 into your function? N minus 1 minus 1/2. Well, the second one, place 8.5 in for your previous and subtract it by 1/2. Why did I put 8.5 in here? Claire, why did 8.5 go in place of f of n minus 1?
Because it says that when n is 1, when n is 1, it's equal to 8 and 1/2.
Great, yeah, and it's saying look at the previous one. So I took the previous one, and now 8.5 minus 1/2 is just 8. Okay, we got to keep rolling. The only way to solve these recursive problems is to keep chugging along the table. I can't solve for n. You might be able to do it mentally for some. Can you do it mentally, Zion? If you can do it mentally, I'm okay with that. So take away 1/2 for every single time. You get 7.5 for the third. Take away 1/2 again, you get 7 for the fourth. Take away 1/2 again, you get 6.5. Yeah. You do. We are looking for 5.5. So the goal somewhere is 5.5. We're getting closer. When 6 is there, you get 6. When 7 is in place of n, you get 5.5. You just found your goal. Your answer is n equals 7. So f of n being 5.5 will only happen when your n is equal to 7. Explicit is the most, or recursive is the most annoying one because it requires a table. Next one. All right, quick little sidetrack into word problems. Emma, can you read example 2?
The go-kart racing charges are $5 for a go-kart license and $2 for each lap. Use explicit rule f n equals 2n plus 5.
All right, so they give you the actual function. They set it up for you, $2 each lap, $5 for the license one time. They want you to find the first 4 lap costs. So if you go on 1 lap, how much does it cost? If you go on 2, how much does it cost? If you go on 3, how much does it cost? You might be able to do this one mentally. Let's set up the table just so it's in your notes. So here's your n, here's your output, f of n. And this is just like an equation. So when n is 1 Indy, what's your f of n going to be? Yeah, 2 plus 5 is 7. When n is 2, Adam, what is your output going to be, f of n? Let him think. Let him think. 2 times 2 is what? Plus 5? So this is a nice explicit rule. It does not have recursive stuff in it, so I'm just rolling along till I get to the 4th one. 2 times 3 then, you might be noticing a pattern. Let's see if it stays the same. 6 plus 5 is 11. Yeah, it does stay the same. I'm just adding 2. So the 4th one is going to be 13. For most of these, you guys will have to write the equation because they'll be a little more complicated than this. If you get one that's this simple, I'm okay with you going from n to f of n like this. Time for that. Thanks. F of 4 was 13. Okay, so you can use this in a word problem. It's the same way. Just make sure you look for explicit versus recursive rules. Let's graph one of these. Caden, read example 3.
A movie rental club charges $20 a month plus a $5 membership fee. Use the explicit rule Fn equals 20n plus 5.
Okay, let's set up a table. It's an explicit rule, which makes me happy because I don't like recursive very much. After we find a few points, we're going to graph it. We're going to find the first 4. When n is 1, what is it? When n is 2, what is the output? When n is 4, what is the output? Plug it in.
I have a question.
Question.
Are we assuming that the $5 membership fee is per month? Or
It's one time. If they just say it's a membership fee, that's one time, and it tells you it's one time because there's no n next to it.
If we can just do that ahead of time,
Sure. This one's a simple equation that you just kind of can plug it in. That's going to be 2 times 20 is 40. 3 times 20 is 65. 4 times 20 is 85. Okay, when you get this done, Indy.
don't you go 6?
Yeah, I'll take a look at it during partners. Did you do it a different way, Indy? Okay, I'll take a look at it. After they have you make the table, you're going to graph it. And when you have f of n, what?
Let's go to 6.
Does it say 6?
Yeah, it's a graph 6.
Nah, we're just going to do fat 4.
What?
Yeah.
That's a wonder.
You just need 4 points. If they have a graph, you actually only need technically 2, because you just need to connect 2 points. So let's just graph this thing and see what it looks like. F of n is actually going to be your y. So the n is actually going to be your x. And when you make a table, you need points that are in x, y form. So your first point is going to be 125, then 245, then 365, then 485. Okay, let's graph it. Over 1, estimate between 20 and 40. It'll look like it may be right there. 245, it's going to estimate to be right about there. 365, right above the 60. And 485, right above 80. Connect your line. Sign board to paper. Does yours look like that? Okay. Put it down. And next page, please.
How come you didn't start it at the 0 or the origin?
So why didn't it start at the origin? There's a reason for that. Anyone know? Why didn't it start at the origin, Kendall? Yeah, so even if you go on 0, or if you get 0 movies, if you rent 0 movies, you still have to pay $5 every month. That's kind of like on Netflix. If you, it's a little different.
It's $20 a month.
It's $20 a month plus $5 membership fee.
That's a mouth.
$5. You're a mouth blunder.
Oh,